Good morning. My name is Will Bishop. I am a senior test engineer at Tesla Motors. I'm going to talk today about some of the production reporting we've been doing with Tableau. A big theme for us as we've been using Tableau and a lot of data visualization in general is this concept of vigilance and response. It's keeping watch on things and responding appropriately. A lot of the theme of this presentation and Tesla in general, as we've grown and been able to keep track of our data, it's kind of teaching this concept of vigilance and response, keeping people looking at data and aware, and Tableau has been a huge part of that. So Tesla, I won't give you a huge amount of background, but we make this car. This is the all-electric Model S. We've received some great accolades in the last year. We've ramped up to production at about 20,000 units per year. We've won Car of the Year for Motor Trend for 2013. There's a lot of hot stuff in the news you should feel free to check into, but I'm assuming if you're watching this, you probably know something about Tesla. But for me, I work in the powertrain group. So this powertrain is all the stuff that makes the car go. So this is battery pack, motor, gearbox, the drive inverter. This is kind of the power electronics that power the motor. So I early on worked in the manufacturing engineering group to make some of the production equipment we use to make the battery pack. Now I'm in the test group. So I design a lot of the tests that we perform for every battery pack and a lot of subcomponents in the battery pack. So that's kind of my context where I'm coming from. I've been there for almost 4 years now. So I'm a veteran, even though I'm a kind of young guy, I'm a veteran in the Tesla world. So a big part of Tesla, our story, is the huge growth we've seen in the last couple of years. The company started out making, a small volume, very expensive electric sports car, the Tesla Roadster. 5 years ago, I was an intern, and we were shipped the first car in the summer of 2008. Back then, we had about 300 employees. We were making roughly 1,000 cars per year. It's roughly a car every 2 hours. These were very much hand-built. Today, we have over 4,000 employees, something like 4,500. We're making, right now, kind of on track for 21,000 cars a year. Small in terms of the big automakers, but very big for us. And that's equivalent to about a car coming off the line every 6 minutes. So, big ramps in production, and with that, this story is going to show is big ramps in our data collection and how important data is to us. So to give you some perspective, I have no idea the square footage, but this is the story of kind of where Tesla has been housed over the last 5 or 6 years. So again, I was an intern 5 years ago. We were building all these Roadsters kind of by hand and the beginnings of our automation equipment in San Carlos, California. A couple of years later, we moved to a facility in Palo Alto. So this is Google Maps view. I just went and got some screenshots from Google Maps, but this gives you a picture of kind of growth. This is a 3-story building, this Palo Alto building, versus a 1-story building in San Carlos. And the day we moved into this building, it was just this vast, empty room. It was amazing to see how much space and say, oh my God, we're never going to fill this. And within 6 months, we had filled it. So the next step was buying the Fremont plant. This is the old NUMMI plant from GM and Toyota. It was a joint-owned plant. So you can see the kind of size difference. A lot of this building is 2 stories, so just an immense amount of space. And again, the analogies kind of run out. This is like city blocks inside a building. But we moved up to the 2nd floor, and again, huge empty space that now is full of manufacturing equipment for the powertrain, and downstairs full of stuff for the vehicle. So point being, a lot of growth. So I can't show you all the exciting pictures of our manufacturing line because we have a lot of IP-sensitive stuff. So here's the cartoon version. So in a manufacturing line, I'm working on production reporting and kind of all the data that we accumulate from running manufacturing lines. So in this world, in this kind of cartoon world, we have a production line, your parts are traveling down conveyors. They will go in and out of different work centers. A work center is just where we assemble XYZ component to the battery or XYZ component to a motor. You might have 3 of the same exact workstations in a work center, this sort of thing. Sometimes you might have a test station. Sometimes you might have a quality inspection station. So kind of different things along your production path. Some people live in the world of kind of the MRB or Material Review Board non-conforming products. Something has a quality issue, it goes here to be reworked, to be investigated. Other people live totally in the material handling world. You have inventory stock being delivered to the line constantly. If you're equipment maintenance, you care about what's my equipment uptime. So kind of all these different places where we can collect data. This is, just some high-level generic stuff that we currently track and would be interested in. Again, if you're equipment, I care about what's my maintenance activities in the last week. Flowing through production, what are all the timestamps of when something went from workstation A to workstation B? Test data, tons of test data from all our battery packs. It's getting stored in a database somewhere. So point being, collect a lot of data in production. So where does it go? The two kind of main places where we're sticking data right now. One is in our manufacturing execution system. This is one of the many 3-letter acronyms in the manufacturing world. This is basically kind of air traffic control software for running production. So if a part is getting pushed around a conveyor, the MES or manufacturing execution system is telling it you need to go from step A to step B. If it failed something, it says okay, you need to go to this rework station. So it's kind of running production. It's tracking things like production orders, where are we moving parts. It tracks quality issues for rework and investigation, and some basic measurements. We made XYZ measurement on a battery. The kind of more in-depth custom test data is in a separate MySQL database. This is kind of our Powertrain test database. This was developed in-house. We have 30 or 40 different schemas that we're sticking various test data in. So this is kind of the more nitty-gritty, in-depth test data. QuickBase is a kind of side database. This is a web interface database. It's nice because it's very flexible. You can kind of make your own front end, and it's storing data in a web tool. Not as enterprise ready as these other 2 solutions, but a flexible option that we use. And Excel is ever present. Someone might just be manually tracking something. I want to track XYZ trial that I'm running. I'll do it in Excel. So we're putting data in a lot of different places. And that data is being consumed, or a lot of different audiences are interested in that. If I work in production, I might care about, how many parts did I make today, and what was the yield? How many were perfect, didn't involve any rework? If I'm on equipment sustaining, maybe I care about, did I finish my preventative maintenance activities for today, or what was my equipment uptime? If I'm on process sustaining, maybe I care about root cause investigation for XYZ failure, this sort of thing. Design engineering, I'm running some trial, I want to see some test data for that trial. So point being, a lot of audiences, sometimes they know a lot about where the data is stored. Sometimes they just say, give me the data from the database. They don't know whether it's an MES, the test database, where, they're just interested in information, really. So, these are some very high-level kind of reporting needs that these are kind of the top 6, top 7 that we're going to look at later with Tableau. Basic ones for production. Hey, how many things did we make? What's the yield? Looking into quality defects, doing some process monitoring, SPC tracking, root cause investigation, open-ended kind of exploration of data, and some fancier statistical analysis. The big point for me when I 6 or 7 months ago look into what tool would be great for reporting is that a lot of this stuff is very heavy on data visualization and data exploration, and it's not that heavy on fancy statistics or complex scripting. This is a particular tool we're looking for is great on these things. So 7 months ago, looked around, explored a lot of different tools. Tableau was one of the great ones that we found. I found out our IT group was already supporting it with some other teams, so we went that direction, and we've been very happy with it. I'll show you what we did before all that happened. So originally, a lot of stuff was done in Excel. A great thing about Excel, you can build in database connections to it. You can point it at, MySQL or Oracle, and people can do kind of simple canned queries. And you can set up I have some query inputs in here, and people can say, oh, I want to look at, some test data between this test time. You can type in serial numbers. You can do some basic stuff. Very useful from, having nothing to having that. And a lot of times, otherwise, if you don't have a nice Excel workbook or Excel file, you just are emailing people. A lot of times it's email the 5 people who know how to get to the data and say, hey, give me this data. So there's a lot of that at Tesla previously. Another tool we use, this is an in-house developed LabVIEW application. This was specifically for test data. This was, just let me go see test results for, various tests that we run. So you can kind of drill down and see low-level measurements. This was kind of designed to look at a particular test execution. So great on that, not great at kind of fancier data visualization, trending stuff over time, that sort of thing. MySQL Workbench, in the test database world, if people were interested, I would teach them how to use this. I didn't know how to use this 2 years ago, so it's been a great education for me. This is, how to use it when I'm querying test data from our test database. And R. This is the free open source statistics software. This is what I do a lot of my work in. It's great. There's a learning curve in there naturally, but really powerful for whatever open-ended scripting, statistics. Lots of great packages out there, but not super user-friendly and not easily shareable with other folks. So a big concept with all this that I'm going to keep coming back to is this quote. It's a quote. I don't know who it's from, so I attribute it to Bill Cosby for no reason. But in the land of the blind, the one-eyed man is king. This seems to be what you would think we would be at, 6 months ago. There's very few people with access to a lot of our data, with easy access. So you would think someone like me who's, able to write a lot of queries, able to do some kind of scripting stuff, would be like, oh, I would be in demand. But kind of the other side of that coin is I'm just kind of a gopher. I'm just kind of the butler. People are emailing, that list of 5 people and saying, hey, give me the data, give me the data. They're spending a lot of their time just pulling basic queries, just doing basic stuff. So a big frustration there is that people were not able to access data, and we're blind in a lot of ways to what was going on. So a lot of this story is about A, providing access, but B, kind of teaching people how to look at this stuff. As we've had more access to it, a lot of my work has just been in teaching people kind of the basics of, or the, what would you say, the kind of data literacy. I guess that's a good term. Teaching people how to look at this stuff. So that's been a really common theme. This is my goofy chart that I think about. This is not proven with any empirical evidence, but in general, my observation is that the more you're looking at data, the more you're interacting with, informative charts every day, the more, fracks, that's what Elon Musk likes to say, frack, the more fracks you give. So this is trying to get more people exposed and interacting and appreciating our production data on a daily basis. So challenges, I already mentioned a couple of these, but to sum it up, poor access to data. People didn't have an easy way to get to data that they wanted to see. Bottlenecks, emailing a couple people to get to that. Inefficient manual data processing. A lot of people are doing stuff in Excel. and clicking around and doing, A, not the greatest job because Excel is not the best tool for the job a lot of times, and B, doing it very slowly and efficiently. And when we were younger, this was a problem. This, kind of blindness to data makes people unaware of stuff that's going on. They can only see what's in front of them physically on the production line, but they're not looking at the other kind of world that the data gives us insight into. So where we are now, or where we're growing, still lots of folks on Excel, which is fine. It's a great tool. Results Viewer, that our LabVIEW app, has been grown into a fancier web tool, custom web tool, which is great. It's free for us to distribute in-house. The bad thing is that we really have one main developer on that, and she is, has taught herself a bunch of this web stuff, but she is the kind of limiting factor for building new things. If you want a new thing on that web tool, you've got to go ask her, and she's got to make it for you. So some bottlenecks there. MySQL Workbench, more people, a growing number, kind of appreciating, oh, okay, I can learn how to query this data and go get what I want. R, we have tripled in size in our use of R at Tesla, at least to my knowledge. I've got 2 people that are slowly using it with me, which is wonderful. But Tableau is the big one. To sum it up, these are just the 3 best things that I like about Tableau. The first thing, which is huge, is it's kind of data source agnostic. We can point it at, our MES data, our test database, recently at QuickBase, and an Excel file at other databases that we have. You can look at that data side by side in the same dashboard. That's a really huge deal because people, again, don't always even know the different places where data is located, and really they shouldn't need to care. They just want some information. So being able to flexibly connect to whatever we need to connect to is a huge deal. It's easy to build really powerful stuff. I could build a lot of what I do now in Tableau in R, but it's not, sometimes it's far easier in Tableau. And especially for non-programmers, we have a growing number of developers, Tableau developers, and they are far more easily able to build stuff in Tableau than learn R for 6 months. And a huge thing to me is this third one is publishing and sharing. Before, a lot of my world was copying and pasting or exporting image files and emailing them to people. It's functional, but it takes a lot of my time, and it's just not a great interaction for them. Now I can make a workbook, publish it in 30 seconds, and from that point on, people can go interact with it without me touching it again for weeks at a time. So that's a huge thing to me, is bringing this data to people is making it easy to publish and share. So going back to those production needs, these are kind of specific ones. I'm going to go through some workbooks that we use today in our factory for various things, have some little data interludes in there for things that have been helpful for us. But yeah, this is where we're heading. I'm hoping to spend most of the time just looking live at Tableau workbooks that we use. Caveat to this is I've tried to go around and clean up all our kind of IP sensitive stuff, so you'll see a lot of super generic names like Part A1. Yeah, not satisfying, but gives you the gist of what's going on. The data has been, I've gone and tweaked stuff, changed calculations, faked a lot of data that's in there, so it's the charts we use in the real world, but the data is mostly fake. And yeah, sometimes the calculations as I tweak stuff were screwed up, so I apologize for that. But let's dive into it. So first one, production counts and yield. So again, this is, I'm a person in the production organization, and I care about, maybe it's just for today. We have other things that are just, status for today, hour by hour. How many parts did we build? But also getting a sense over a long period of time, how many things am I making? Am I on track? What was my yield like? So this is something we use for those folks. So we got at the top, and this is data coming from MES. This is coming from multiple tables at MES. This is just how many parts, unique parts, did I finish in that day. We can have a goal, We can move this around. You can do, fancy highlighting. We just have a line there. But being able to do things like, is one shift, producing more than another shift? So we got, day and night shift on this line. So is one working, better or worse than another one? This middle chart is kind of the overall yield for that day. This is basically, if you hover over here, the number of unique serials we made on the line in that day, and the number with open items. Open items is just kind of a catch-all for, quality issues, something we had to look into, investigate, maybe rework. So on this day, we had 85% of parts were perfect. They didn't have any issues. So a cool thing about this, and we can kind of look, this is kind of bucketed by day. We can look down here and see, okay, what's the breakdown by different work centers, different steps in the production process. This is kind of the steps we go through to build something. A huge thing in Tableau and my experience in publishing it and using it myself is the kind of actions, highlighting and filtering. So if we have, a particular day we're interested in, say we're just interested in the 12th, we can filter down to just that data and say, okay, what happened on that particular day? What was kind of the thing that was affecting my yield the most? So we see, oh, this station and this station is not doing really well. You can kind of click through days and say, this is kind of a consistent pattern. We can then go dive into those particular stations and see, what can we do to improve the situation. But being able to track this stuff, this is basic stuff. This is how many things did we make and what was our yield. But again, a lot of this was difficult or impossible to get in the past. So this is a big deal for people to A, just see the data, and B, kind of, play around with trends, click around and highlight stuff. Can slice by part and say, is one part doing better or worse than another? This is driven by, this is a parameter that's selecting certain columns to display. You can filter, I just care about the A parts, filter that out. So one useful dashboard that we use today. So I want to take a moment and talk about how we access data with Tableau. A huge amount of our connections are data extracts. This is really useful to us. Well, I guess I'll talk about what is an extract. A lot of people probably use them already, but this is the concept of kind of, I want to take a chunk of data from the test database. Say I only care about test results in the last 2 weeks for a part XYZ. So I can set up an extract, grab just that data and stick it in Tableau. Then I care about, for that same part, okay, how many, parts and quality defects did we have in that same 2-week period? Go grab that, stick it in Tableau. This is really great because we're only grabbing the data we care about. Data a year back or, for another part that we might not care about right now, we don't have to look at. We don't have to kind of add to that connection. That kind of makes everything run faster on the front end, which is great. We have live connections at times when we really need to, but for the most part, people, these are our little one-eyed people, they're looking at the Tableau server, and Tableau is once a week getting full extracts, chunks of data, and hourly it's getting incremental extracts, so it's whatever is recent in the last hour. This works great for us because a lot of our data is kind of frozen in time historically. A test runs, it gets put in the test database. We're not going and changing those test results. That's just the historical record. So incremental refresh works great for us. Places where we're going back and changing those historical records, we either need to use a live connection or use full refreshes more frequently. But a couple benefits that are huge for us is, again, take only the data that you need. We have tables that are adding 2 million rows a day. If I only care about a certain subset of that, that means my query runs a lot faster. That means my front-end Tableau user interface runs a lot faster. Another big thing is decoupling these end users from these reporting servers. Right now, we're going through a lot of work to make a much bigger, faster, better reporting server for our manufacturing execution system. So right now, we're pointing at something that is older, slower, wasn't indexed perfectly well until recently. So it's been very helpful to, instead of point live at that slower database, pull just a chunk of data that we need, and front-end users, it's super fast to them. They don't know the difference. Another thing is just if you have 50 users versus one user, you're not making 50 connections. You're still having Tableau as the only connection to this database. You can have a lot more control over this extract connection. And as you add users to the front end, you're really just hammering the Tableau server as opposed to these back-end reporting servers. This has been a really useful tool for us. As we get fancier, reporting databases, we're going to go to more live connections. But in general, we love extracts. We probably have 40 to 50 data connections with extracts, pulling chunks of useful data for us. And yeah, it's a big deal for us. The last one is kind of controlling connections. Even the developers that are, building Tableau workbooks, this is a great way we can make one extract that multiple developers can use. They don't have to make 3 separate connections for 3 separate people. So kind of sharing connections and also documenting that one connection is much easier. So this is very recommended from us. So next workbook, quality defect tracking. Some people's whole world is every day coming to work and saying, okay, let's diagnose the issues for the day. So to walk you through this, we got some parts. Usually we'd have, this is kind of old data back in August and July, kind of fakey numbers, but usually you'd be able to zoom in on, just show me the last 10 days or the last 30 days, whatever. Being able to zoom around in time is a really big deal. Only show me, these parts. I don't care about these other ones. And again, using kind of flexible slicing or faceting, splitting data by important variables is really helpful. But basically, we have kind of 3 different views of the same data, which is really just count of defects, count of quality issues. So this is kind of a trend over time. Do we have, we had kind of a lot of defects back here. As we go forward, we're dropping down. This is Paretoing those same counts out by work center. So what work center is producing the biggest number of defects? And finally, just by defect, which is our most common defect? So a huge thing for me and for folks looking at this stuff is, there's no one way to look at the data. Usually to kind of get a full picture, you have to look at it from multiple angles. So this is an attempt to do this. This is kind of look at it in time, look at it by work center, look at it by defect. And again, using filters, we can say, okay, I clicked on just this work center. We filter down to just that work center. So kind of having these interactive filters to say, okay, this work center, this defect, let's look at the trend over time. So this kind of interactive filtering lets people play around, notice trends, look at the data from different angles. And then at the end, if they zoom in, say we care about, just this fake issue, usually you'd be able to come in here, I chopped them out, but you'd see for a particular part and serial number, you could say, okay, this was the quality defect note that someone wrote when they, were doing the quality inspection. This is offline rework notes, so it gives you some context, drill down from kind of high level down into individual serial numbers. So again, this is used every day by folks in process sustaining to kind of dig into this stuff, look for trends over time, and just do their day-to-day job. And I think I already showed this, but yeah, a really useful thing, splitting by different variables. Do we have, way more of this issue on the night shift than the day shift? So noticing stuff like that. Again, allowing people to, not just a static report, but something they can interact with, play around, explore, yeah, they can find stuff that I would never have found if it was just me looking at the data. SPC Trend Charts. SPC is statistical process control. This is means a lot of different things in a manufacturing context. One of the basics is a trend chart or a run chart with statistical control limits. So we use this in a bunch of places, and again, this is an attempt for people not to when you can look at this data and kind of look at what's going on live, you can see problems before they start, before they really hit you hard, which is a huge deal for us as we grow in volume. So this is, again, kind of meant to be a generic chart. You can click around, you know, fakey names, and say, okay, I care about, you know, various parts. Actually, I'm going to take that one out because it makes it a little busy. Over some time period, you can say, you know, I want just the first test that was run on a particular part and serial number, or all the tests. You can choose a particular test that was run, and then you can go in and choose different test step, kind of part of the test where we're taking measurements. A useful thing here is kind of, you don't know what the scale is going to be for those measurements, so I kind of make a generic filter. You can use zoom for this, but I found this as more useful. So by default, I kind of have wide filters. Sometimes you have some extreme outliers that are blowing your window way open. But by just literally filtering out, excluding those points, we can kind of zoom in on the typical things. So we can say, okay, you know, we have some control limits, and the red is a test limit. So we can say, oh, okay, this metric and this metric, you got a lot of stuff drifting, not beyond the test limit, not failing, but, you know, going over the control limits. This is basically the fancier statistics that we do in Tableau. You know, not super complicated, not requiring scripting language, but, you know, really heavy use of custom calculations and window calculations. And, you know, this control limit is calculated off the data just in this pane, and it's, you know, looking at a moving range among all these data points. It's doing some basic stats on that. But yeah, I mean, when we look at another time window, when we look at another test metric, these control limits are kind of calculated on the fly, which is really valuable. I think we're chopping off some stuff with the filter. Aha. That's all of it. Yeah, and for some context, you know, histogram down here, mean, test limits. This is a 3 sigma, plus or minus 3 sigma band. But yeah, just allowing people to poke around and, you know, monitor from a day-to-day basis. Is stuff trending out of control? Are we getting near our failure limit? Eventually, at the Tableau conference, I'm going to talk here about some documentation of all this stuff. I am not ready to talk about that now, so you'll have to come to the live show to see that. Yeah, but we've been improving in our documentation of how we use Tableau, documenting with revision control all our workbooks, data connections. This is a big thing that, you know, I'd be curious to see how other folks do it. But yeah, I'd be interested to talk more with folks at the conference about this. Process monitoring. This is one of my favorites. This is similar to those SPC charts. But in this case, did I get rid of my, aha. So in this case, we have some stations that have, you know, will run fine most of the time, but sometimes they will false fail parts. So it's, reading a barcode on a part, and if the barcode is misaligned or, the part is not held in the right angle to the barcode scanner, it'll start misreading that barcode or not being able to read it. So it's not that the part is bad, it just can't read this barcode. So this is an issue that comes and goes on the machines. Most of the time, machine runs perfect, but after a week, maybe the barcode scanner gets misaligned or something happens with how that part is held. So this is a monitoring tool we've been using with a sustaining engineer on the line to look at, so these are a bunch of different stations. We got a bunch of stations in parallel. A nest is kind of where a part is held in that machine. And each of these is a station and a nest saying, okay, we tested X thousands of parts. We rejected 19 because we couldn't read this barcode. So we got some percentage rejection. And is that a problem? Most of the time, this is, 4 out of 5,000, 5 out of 5,000, 12 out of 5,000. Most of the time, running great, barcode scanning perfectly. But sometimes you get a station with one or multiple acting up. So this kind of high-level view, you're able to click on and say, okay, I care about, let's see the story for this particular station. So this shows us kind of the trend of that particular station in each nest over, chunk of time, 2 days. So these colored lines are those percentage rejects for each particular nest, these individual nests. So we can say, oh, this brown one, nest, F, is acting up. And in the background, you get some context of how many parts are we talking about. If we dipped down and tested 5 parts and we had a huge percent rejection rate, we might not care about that because our sample size is really small. And then to add some additional context, with another data connection, this is separate database even, separate data connection, we can show for the same period of time equipment logs. So, what we're trying to do here is, if this is acting up for a continued period of time, is log this machine down, tell maintenance to come check out this barcode scanner. So this is, a log, someone logged this machine down or put in a maintenance alert to come check into this barcode scanner. This happened again, and this is kind of the success story we're looking for. Is someone came, did some repairs on this thing, and now it's running great. So this is kind of the point of this process monitoring, is keep an eye on this, be able to drill down more deeply and see kind of a story of what's happening over time, see context for what was the actions taken on this, and yeah, drive this to improvement. We're hoping over the next couple of months all these will just be green all the time. Yeah, so this has been a very helpful tool for people. Next one is flexible trend charts. This is similar to those SPC charts, but this was made particularly for a guy in my test group who he just wants to see trends of test measurements over time, and he wants to look for patterns, is one piece of equipment or one part, testing differently than another one. So this is, I was realizing as I was making this, is I do a lot of, well, I'll walk you through this first and we'll talk about that. This is a bunch of test data over time, the last, 30 days, and we're looking at a particular prop tag. A prop tag is just the name of a particular test measurement. We can filter by parts again. We can pick certain pieces of equipment that we want to look at. There's multiple testers in parallel. This is one of his requests. He said, sometimes he runs a bunch of tests as a trial, so he wants to either filter just his name or filter himself out. And similar to that, if he's running a trial, he wants to exclude that from the data set so it doesn't kind of screw up the charts. So again, providing people with, what is from the start, just a really basic scatter plot. We got a scatter plot. Each point is a part and a measurement. You get some context. These are, test limits for that measurement. You can see that with the red lines. The gray band is plus or minus 3 standard deviations of the data that we see. Again, we can kind of filter stuff out if we want to, and a histogram of the same data. The table at the bottom is, CP and CPK capability calculations, some useful calculations for evaluating basically how tight is my distribution inside my test limits. But a big thing, it could go this far, and this would be a huge help to a lot of folks. But a lot of people's questions revolve around, hey, is this part different from this part? Or is this piece of equipment acting differently from this other piece of equipment? So we can see here, this green tester 5 is having higher measurements than the other ones. Maybe, that meter, maybe that's, simple bias, it's not important. Maybe that's something important with the measurement or the repeatability on that tester. Similarly, splitting by or faceting by different variables. Now we slice this by, and we can see kind of the overlap of the different pieces of equipment. So again, trying to design stuff that's not just a useful view from what they, one thing they want to see, but the ability to explore and tweak stuff and answer questions that they might not have knew to ask at the beginning, or answer questions without going to me again. So I do a lot of this stuff in R, but I started to do this in Tableau, and both for my own use and for other people using it, this is, really simple to interact with and hugely powerful. We have another quick data interlude. So that last workbook we were looking at, those trend charts. That's one of the few cases where typically we use a live connection. I said previously most of our connections are extracts. We do live connections in places where we absolutely have to have up to the minute fresh data, and just give me what happened in the last 8 hours or the last day. This is a case where we're looking at some test data, and instead of doing an extract for the last 7 days. If we did it for the last year, it would be an immense amount of data, and we'd basically be copying all our data to Tableau, which is kind of silly. So instead, this is a case where we use live connections and insert parameters in the query to kind of only pull the chunk of data that we're interested in. So we're using the custom SQL option in a data connection. So this is kind of a fakey query, but the big part is in that custom SQL you can insert a parameter. It doesn't even have to be made when you make the data connection. I can type in whatever I want, so I can type in a start date and an end date and some prop tag, the name of some metric that I'm interested in. So now when I change this prop tag, instead of pulling a million rows for 100 different test metrics, we're going to pull the 1,000 rows that we're interested in, just for this prop tag for whatever date range someone is interested in. So this is a huge thing because it gives people the flexibility to look at whatever test metric they're interested in, but it's a really this query we can make sure that we're using the right index columns. We're kind of controlling how they're doing that query. So yeah, kind of controlling the connection, but giving them the flexibility to look at what they want. This is one of the few times I've found custom SQL to be useful. It's kind of limited because Tableau puts a wrapper query around that, which can make very large queries slow. But in this case, this is a kind of small, tightly controlled query that gives us a lot of flexibility. Root cause investigation. Again, the story here is letting people explore and kind of slice by different variables. This is a case where we have some failures. This is kind of junk, multiplied numbers. But we have a bunch of failures, and we have a really complex assembly. Maybe there's 5 different parts interacting, and we have, some different variables. We have different pieces of equipment. We have different sides of the part. We have different part numbers. Shifts. We have, kind of a subcomponent part interacting. We have the sides, side A or side B of kind of a subcomponent. There's a lot of different variables going on. So having something that can look again at that data from all kinds of different angles and people can explore and discover relationships is a huge thing. Again, I would do this in R by myself, but this gives anyone with a Tableau license the ability to go and kind of slice the data in different ways. So I know already, these failures are related to side. We get way more failures on side X than side Y. And so the question is, why? Is this related to piece of equipment? So, nothing super obvious. I mean, this literally you can go through and tweak variables and say, is there something that is super obvious that stands out that, we're getting failures related to? So shift, pretty even. These I kind of know there's just more of those parts than other parts, so I know that's not a big deal. But this unit side, this is one of our subcomponents, so side A versus B, we're getting a ton of failures on this side B versus side A. So this is like, wow, we need to go check into, part side X, subcomponent side B. This is, huge number of our failures are related to that. And again, clicking on here, you can kind of see the story over time. How is this trending over time? Did we do something here that's dropping our failures? Did we do something here that made them go up? So letting people explore different stuff, see trends over time is really powerful. I know another. This was another useful pattern. On this particular kind of subcomponent, we get a bunch of failures for side B. Actually, yeah, people were interested in these. We get a bunch of failures of just this side and just this side, so kind of digging into that. But again, kind of with the use of selectable parameters and a bunch of variables, you can explore kind of the data differently and figure out stuff. And kind of making this available to more people has been a huge thing. So we're almost there. This is just kind of a flashy last one that was fun. Tableau has been great for me to just do kind of open-ended data exploration. When I get new data, I used to go throw it in R. Now, more and more, I throw it into Tableau and poke around. But this is one pretty fun project that we were doing. In this case, we again have some complex assembly of a bunch of parts. We do, probably 30 different measurements on those parts throughout the course of production. And the question is, we have some metric that is kind of our metric of success. This is the one we're trying to make small. And the question is, are those other metrics correlated to this one? When this is high, is metric G also high? And so this is a tool. This is called parallel coordinate analysis. That's nothing fancier than doing some side-by-side plots of a bunch of metrics. The key is you take all those measurements and for kind of the typical range of a certain measurement, normalize it down from 0 to 1. So 1, it just means very high for, in the tail end of the distribution for any given metric. 0 is on the low end. So over here we can see kind of histograms for a bunch of different metrics. This is our metric of success. I color-coded them into kind of bands for, red is high. We don't want high. So we can do things like, okay, well, we don't want high. When we're high on this one, are we high or low or something on any other ones? And so we see, oh yeah, when we're high on this first one, we're also high here. We're low here. This is just kind of noise. So this is, maybe there's nothing going on with the other ones, but we should explore relationships between these two. Same thing. When you're low here, do we get any prediction? We want things to be low in this case. So, if we control, there's some other ones in there. So people could literally, go in, click every metric that was available, and, look for trends. This is like super open-ended exploration to say, what should we dive into? We have 30 parts that we could dive into. Let's pick 2 that seem promising, this one and this one. So this was a fun application, kind of pushing Tableau to the limits at first. It was a great learning tool for me, but great exploration. So again, I'll wrap up pretty quickly, but a big story of this is, in this land of the blind, is using Tableau and a lot of other tools to both give people access, but more importantly, to teach them how to do this kind of data exploration, how to see from this different perspective. We're used in Tesla to running really fast and setting up production lines in a year's time. So now it's improvements from this point need to be driven not by, I guess the problems we're facing are not always obvious now. It takes looking at the data to see what's going on. So a lot of it has been us teaching folks how to look at this data, how to explore on their own, how to see by themselves. That's the kind of, teaching folks to see. That's kind of the kind of ending catchphrase. Yeah, it's been an adventure. We have a lot farther to go, but Tableau has been a fantastic tool in this growth. Yeah, I look forward to the conference and taking questions from folks in person. Yeah, hopefully I'll have some even better presentation to give you then. But please come talk to me if you come in person or see this. Thanks very much.